Hello everyone, I am Akash. In today's video, we will solve a question on linear algebra from CMI M.Sc PhD Entrance 2021 exam. Question is, let A belongs to M2 over R, that is vector space of 2 cross 2 matrices over real numbers, be a non-zero matrix. Okay. Pick the correct statements from below. We have given 4 different statements and we have to determine which of these given statements are correct, that is true. So let's begin the solution. We will examine one by one each of these given statements. So let's start with the statement A. Statement in A is, if A square is 0 matrix, then I2 minus A whole to the power 5 is 0 matrix, where I2 is 2 cross 2 identity matrix. Is this statement is true? No, it is a false statement. We can easily find counter example. For example, consider the matrix A with entries 0, 0, minus 1, 0. Okay. Then clearly we see that A is non-zero 2 cross 2 matrix. Okay. Now let's compute A square. The matrix A square is the matrix with entries first row into first column 0, first row into second column again 0, second row into first column minus 1 times 0 plus 0 times minus 1, 0, second row into second column again 0. So we see that the matrix A square is 2 cross 2 0 matrix, which is a required condition. A square is a 0 matrix. Now let's compute the matrix I2 minus A. Okay. Now I2 minus A is the matrix with entries 1 minus 0, that is 1, 0 minus 0, that is 0, 0 minus times minus 1 plus 1, 1 minus 0, 1. So I2 minus A is the matrix with entries 1, 0, 1, 1. Okay. Now let's compute powers of this matrix. Say I2 minus A whole square. I2 minus A whole square is nothing but I2 minus A times I2 minus A. So this is equals to the matrix with entries 1, 0, 1, 1 times matrix with entries 1, 0, 1, 1, which is equals to first row into first column 1, first row into second column 0, second row into first column 1 times 1 plus 1 times 1, 2, second row into first column again 1. Okay. So I2 minus A whole square is the matrix with these entries. Now I2 minus A whole cube, which is equals to I2 minus A whole square times I2 minus A. So I2 minus A whole square is this matrix 1, 0, 2, 1 times matrix with the entries I2 minus A 1, 0, 1, 1. So this will become first row into first column 1, first row into second column 0, second row into first column 2 times 1 plus 1 times 1, which is 3, second row into second column 1. Okay. So I2 minus A whole cube is this matrix. Observe the pattern here. Here power is 1, so this entry is 1. Okay. Here power is 2, so this entry is 2. Okay. Here power is 3, so this entry is 3. Okay. And rest of the entries are same in all of the powers. Okay. So in general, we have I2 minus A whole to the power 5 is the matrix with the entries 1, 0, 5, 1, which is clearly a not equals to 0 matrix. So there exists a matrix A which is a non-zero matrix such that A square is zero matrix. A square is zero matrix. But I2 minus A whole to the power 5 is non-zero matrix. So the statement in A is not always a true statement. So it is a incorrect statement. So we discard it. Okay. Now let's move to the statement in B. The statement in B is if A square is zero matrix, then I2 minus A is invertible. Is this a true statement? Yes, this is a true statement. To prove it, observe that I2 minus A times I2 plus A is equals to I2 square minus A square. But I2 is 2 cross 2 identity matrix. So its square is identity matrix itself. So I2 square is equals to I2 minus A square. A square is 0 matrix. So I2 minus 0, which is equals to I2 matrix. Okay. And so we observe that the product of these two matrices is equals to identity matrix. And we know that a square matrix B is invertible if and only if there exists a matrix C such that B times C is equals to identity matrix. A square matrix B is invertible if and only if there exists a matrix C such that B times C is equals to identity matrix. So by this result, we have as product of these two matrices is identity matrix. So we have the matrix I2 minus A is invertible and its inverse is equals to I2 plus A. Okay. So the statement in a B, if A square is zero matrix, then I2 minus A is invertible is a true statement. That is correct statement. So we mark it as correct. Now let's move to the statement in C. The statement in C is if A cube is zero matrix, then A square is zero matrix. Is this a true statement? Yes, this is a true statement. To prove it, observe that if A is 2 by 2 matrix, then characteristic polynomial of A is of form lambda square minus trace of A times lambda plus determinant of A. If A is a 2 by 2 matrix, then its characteristic polynomial is of this form. Okay, and we know by Cayley-Hamilton theorem that every square matrix satisfies its own characteristic equation. So therefore, by Cayley-Hamilton theorem, as A is a square matrix, so it satisfies its own characteristic equation. So this implies A square minus trace of A times A plus determinant of A times identity matrix is equals to 0 matrix. Give this as equation first. Okay. Now we have given that A cube is 0 matrix. Since A cube is equals to 0 matrix, so this implies determinant of A cube is equals to the determinant of 0 matrix, which is equals to 0. And by properties of determinant, determinant of A cube is nothing but equals to determinant of A whole cube. So we have determinant of A whole cube is equals to 0. So determinant of A whole cube equals to 0. So this implies determinant of A equals to 0. And by using this, equation 1 imply A square minus trace of A times A plus this term will become 0 because determinant of A is 0. So equals to 0 matrix. Give this as equation 2. Now multiply both sides by a. We get a cube minus trace of a times a square is equals to 0 matrix. Okay, and this implies a cube is equals to trace of a times a square. But we have given that a cube is 0 matrix. So this implies trace of a times a square is 0 matrix. But this implies either trace of a equals to 0 or a square is 0. In either cases, we have a square equals to 0 matrix. Why? Because if trace of a equals to 0, then equation 2 implies this term will become 0. So we have a square equals to 0. So if trace of a equals to 0, then we have a square equals to 0. And if a square equals to 0, then this already holds. Okay. So in either cases, we have a square is equals to 0 matrix. Thus, if a cube equals to 0 matrix, then we have a square equals to 0 matrix. So this statement is correct. That is a true statement. So we mark it as correct. Now, let's move to the statement in D. The statement in D is if a square equals to a cube not equals to 0 matrix, then a is invertible. Is this a true statement? No, this is a false statement. We can easily find counter example. For example, consider the matrix A with entries 1, 0 and 1, 0. Okay. Then this implies A square is the matrix with the entries 1, 0, 1, 0 times matrix with the entries 1, 0, 1, 0, which is equals to first row into first column 1 times 1 plus 0 times 1, 1. First row into second column 0. Second row into first column 1. Second row into second column 0. So we observe that if A is a matrix with the entries 1, 0, 1, 0, then A square is again equals to matrix A. Okay. If A square is again equals to A. Now let's compute A cube. But a cube can be written as a square times a. Okay. But we know that a square equals to a. So this is equals to a times a, which is again equals to a square. But as a square equals to a, so this is again equals to a. So overall, we have a cube is equals to the matrix A. Thus, a square is equals to a cube is equals to a. Both a square and a cube are equals to the matrix A. And A is this matrix, which is clearly non-zero matrix. Okay. So this condition a square equals to a cube not equals to 0 matrix is satisfied. Now, is A is invertible? The matrix A here is invertible? Clearly, it is not an invertible matrix. Why? Because determinant of A is 0. So, A is not invertible. Okay. So, there exists the matrix A which is not invertible but satisfies this condition. Okay. So if this condition is satisfied, then A is invertible? No, not necessarily. So the statement in D is not correct statement. That is, it is a false statement. So we mark it as incorrect. Okay. So the answer to this question is statement B and C are correct statement. That is, they are true statements. So if you found this video interesting and helpful, then please like and share this video and subscribe to our YouTube channel. Thank you for watching.